Hey guys, so today we look at a program to find the product of numbers from 1 to n or the factorial of a number n using recursion. Now we've already completed the program to find product from 1 to n or factorial of n using loops, and we have also done the program to find the sum from 1 to n using recursion. I will be linking both these programs in the description box below. Now looking at product from 1 to n using recursion. So let's say I'm going to call the function of fact, and let's say n is equal to 5. So what is 5? Factorial of 5? Factorial of 5 is 5 into 4 into 3 into 2 into 1. Like we did for the sum program, let's shorten this into sub-problems so that it becomes easy for us to solve. Now, 5 into 4 into 3 into 2 into 1. This 1 is a multiplication constant. So, let's say if you're finding the factorial of 1 or the factorial of 0, we know both the values are equal to 1. So, factorial of 1 is also equal to 1. Factorial of 0 is also equal to 1. Now we can say that 5 into 4 into 3 into 2 into, let's call this as factorial of 1. Okay. Now how do you find factorial of 2? Factorial of 2 is equal to 2 into 1, which is 2 into factorial of 1. So this will be labeled as factorial of 2. The remaining will be copied exactly the same way. Now next, finding factorial of 3, which is 3 into 2 into 1. This 2 into 1 is already written as factorial of 2. So 3 into factorial of 2 can be labeled as factorial of 3. Copying the remaining into 4 into 5 and now factorial of 4. So factorial of 4 is equal to 4 into 3 into 2 into 1, where this part is already labeled as factorial of 3 into 4 gives the value of factorial of 4. So this can be labeled as factorial of 4 and into 5. This will be 5 into 4 into 3 into 2 into 1, which is actually factorial of 5. So my LHS and my RHS is the same. I have degraded this from a big problem into a smaller problem. So if we are supposed to find, let's go at it backwards. So if you're supposed to find factorial of 5, it is 5 into factorial of 4. Factorial of 4 is 4 into factorial of 3. Factorial of 3 is 3 into factorial of 2. Factorial of 2 is 2 into factorial of 1. This is already written as 1. So this is our ending condition. N gets the value of 1 when the factorial of n gets the value of 1 when n is equal to 1. When n is equal to 0, also the value is 1. When you write it as if n is equal to 1 and return 1, the problem happens if the user enters the value 0. So you have to state for both the conditions, for factorial of 1 as well as for factorial of 0. Because if that value is entered, you have to find a value for that as well. Now we know through this we can generalize that factorial of n is equal to n into factorial of n minus 1. This is very common in mathematics also. We write n factorial is equal to n into n minus 1 factorial. This is a formula existing in mathematics also. We have just written it in this format. Now you see there is a recursive function called here. And where does it terminate? It terminates when n's value reaches 0 or 1. So now let's write the factorial function call. It's exactly similar to the sum function. We know it will be returning 0 or 1 when it will be returning 1 when n's value is equal to 0 or 1. So you can put it as int data type. So int factorial and int n is passed. So whenever the value of factorial n is equal to 0 or the value of n is equal to 1, we can write return 1. Now you might ask if this can be shortened and written as n less than or equal to 1. The problem is if n is written as a negative number, there also you might have a trouble. So you have to handle the n. If you're handling the n negative in the main program, then no problem over here. So if n is equal to 0 or n is equal to 1, return 1. Else what do you return? You return n into factorial of n minus 1, which is the recursive call. These brackets are not mandatory. If you don't add it also, it will work. So this part is our factorial function. Now let's see how this executes. Let's say I am going to take the value n is equal to 4. So first fact of 4 is being called. So we have a function call stack being generated. First fact of 4 will be called. Now 4 is equal to 0 and 4 is equal to 1. Both are false. Hence the combined function is false. Therefore the next what is released is 4 into fact of 3. Now this is the next function called with n is equal to 3. Moving on, 3 is equal to 0 and 3 is equal to 1 is false. Thereby it activates the next return function 3 into fact of 2. 2 is equal, then n is factorial is called with n is equal to 2. 2 equal to 0 and 2 equal to 1 is false. Therefore it activates the next statement 2 multiplied by fact of 1. Now fact of 1 is written as 1. So this will return the value as 1. So 2 into 1 is equal to 2 will be returned back to the previous function call. So once that is returned back, 3 into 2 will be calculated and the value is 6. 6 will be returned to factorial of 3. So this will get erased and 6 will be the value which is replaced over here. 4 into 6 is equal to 24. This will be passed to the function call. So when you display your function call's value inside your main function, it will give you the value 24. So this is how you find product of numbers from 1 to n using recursion or factorial of n using recursion. Now we'll look into the coding part. So coming to the coding part of printing the product of numbers from 1 to n or the factorial of n. This is the code that I had already posted regarding finding the sum of numbers from 1 to n. I will link the video in the description box below. Now for changing this for factorial, you can write here in your main program, the changes you can write is factorial of n is equal to, and let's this function called be fact. Now changing this function name to fact. In factorial, if n is equal to 0, we'll be returning 1 as factorial of 0 is 1. Now this will be asterisk sign and the function called will be factorial. Yes. So let's execute the program. So factorial of 5 should be 120. So I'll put 5 and it should display 120. Let's see if it works for 0. Enter n 0 and 0 factorial should be 1. Yes, it works. Thank you.